Welcome back. In this video, we're going to take a closer look at clamping and get a bit of a deeper understanding about how it works in gas. Now, we've clamped the changes to our health and our mana, and if we go back to our attribute set to our pre-attribute change function, we see that we're getting the new value and we're clamping the new value. So where does this new value come from? Well, it comes from the calculation performed by our modifier in a gameplay effect when a given attribute changes. Now, of course, this function is called even when attributes are set directly. But if this is from a gameplay effect, that modifier returns the result of a calculation, and this is receiving that. And of course, we're checking its value, we're clamping it and making sure it doesn't go below 0 or above the max value, right? But let's see how this works with a little bit of testing. And you may have discovered this problem that we're about to see by playtesting on your own. So I'm going to show debug, right? And we have 50 health and our max health is 100. Now, if we step into the fire, we've now made our fire take 5 every second. Okay, so far so good. But what if we go and increase our health? Here we'll pick up a health crystal. It's going up to 61. And let's pick up another one. Okay, it's going up to, it's 100. And let's pick up another one. And even though we are clamping our health, we see that our health is not higher than 100. But I'm going to step into the fire and our health isn't changing. So what's going on here? Why is our health not changing? Well, I'm going to close the editor and come back here and take a look at post gameplay effect execute. And I'm going to check to see if the attribute that's being changed is our health attribute. We can check that by saying if, and we're getting it from our data here, dot attribute. That gives us a f gameplay attribute, and we can compare that with get health attribute. So if we make it into this if statement, we know that the attribute changed is the health attribute. So what I'd like to do here is I'd like to see what that value is here in post gameplay effect execute. So let's go ahead and just print it to the screen. I'm going to say gengine add on-screen debug message, and we'll just give it the key of 1, time to display 3.f seconds, f color red, and f string, printf, and we'll format a string that says health %f followed by get health. Okay, so we're going to print a string that says health and the value of our health. Let's run this in debug mode. Debug mode is always more useful because we can place breakpoints and check the values of things. So we're going to run in debug, and let's see what happens here. Okay, so I'm going to show debuggability system. And now I'm noticing that there's red text up here, and we chose red for our color for the debug message. So we're going to have to try to strain our eyes a little bit to see what it says. But we see health is 45, and right here, health. Same value, basically, is what the bottom line is. We're getting consistency, right? But let's see what happens when we do what we did before. Now, how did we discover that bug where we stopped taking damage from that fire area? How do we repro that issue? Well, remember, I picked up a couple health crystals. I let my health go all the way up to 100. And then I picked up more health crystals, okay? And then I stepped in the fire. Okay, so we see in our message and on show debug, we're getting 100, and we're not going down. So it's the same value here, both in post gameplay effect execute and here in pre-attribute change. So how come we stopped getting damage? Well, what I'd like to take a look at is the value here of new value before we clamp it. So I'm going to repro the bug by going and picking up a couple health crystals, and then going way up past 100, or at least trying to, and then going and stepping in the fire. And then I'm going to stick a breakpoint right here, and we're going to hit that breakpoint because we're in the fire. Now, let's hover over new value. We see that it's 160, and that is not what we expected, right? Because we should be clamping every time. So why is it 160? Well, pre-attribute change is getting new value from our modifier on the gameplay effect that's being applied. And then we're clamping it before the attribute changes. So that's great. But this clamp here is not going to permanently change that modifier. It just changes the value that is being returned from querying that modifier. And if we have some other gameplay effect that's going to have its own modifier queried, it's going to recalculate the value from current value. So it's kind of like the value was never actually clamped. We clamped it before the attribute changed, but that modifier recalculates. So if we continue this, and then we hit our next breakpoint, we see that it's $155, so we are going down thanks to that fire area, but it shouldn't be $155 in the first place, should it? Now, we can properly clamp this by clamping again over here in post gameplay effect execute, because this happens after the gameplay effect has already been applied. We can clamp that value again, and we don't have to worry that since we're changing it again, maybe it's going to replicate again down to clients. No, we can change it here, and there will only be a single replication resulting from changing the attribute's value. So I'm going to remove that breakpoint and continue. And we'll close out of the editor. And here in post gameplay effect execute, if health is the value being changed, then we're going to say set health equal to fmath clamp, get health. We're going to clamp between 0 and get max health. So let's run in debug mode, get max health, to being gameplay effect execute, if health, and continue. And we'll close out of the editor. And here in post gameplay effect execute, if health is the value being changed, then we're going to say set health equal to, so we'll pick up the fire. And look at that. We see that our health is going down to the correct values. Why? Because we're clamping. We're not just, this just changes the value returned we're actually setting the health. So yes, we can clamp here, but remember that all this does is clamp what's returned from querying the range. That's basically all that this function is good for. But remember that all this does is clamp what's returned from querying the modifier. Anything else that queries the modifier, again, is going to recalculate what's returned from the modifier of any given effect. We are going to actually set the value to a clamped value here in post-gameplay effect execute, and when all is said and done, the actual value will be set here. Okay, so I can go ahead and remove this on-screen debug message, and now that we understand clamping a little better, let's go ahead and clamp our mana here as well. So if the attribute is get mana attribute, then we're going to go ahead and clamp it between the value of get mana and get max mana. And of course, we're not calling set health, we're calling set mana. And now we're clamping mana as well. So great job. I'll see you in the next video. Welcome back. In this video, we're going to learn another way to initialize our attributes. So far, we're just calling the
property game attribute. Okay.
These init functions, and that's not my preferred way to do it. And as I mentioned, there are multiple ways to do it. Now, the way that we're going to do it in this video is not my preferred way either, but you should know about it just because it's an option that's there. And that's to initialize the attributes with a data table. Now, my preferred method is through a gameplay effect, and that's the method I see most commonly, but for educational purposes, we're going to cover how to do it from a data table. And to do that, I'd like to add some more attributes to our attribute set. because this project is going to involve more than just health and mana. So I'm going to open my Aura attribute set header file. And before I do that, I'm going to close all other tabs except for the CPP file, and then head on over to the header file, and let's just go through the boilerplate steps to add a few more attributes. Now, these are my vital attributes, at least what I'm calling vital attributes. So I'm going to add a multi-line comment here that says vital attributes. And the attributes that I'd like to add now, I'm going to categorize a little bit differently. I'm going to RPG. I'm just going to have 4 primary attributes, and you can even have less than 4 primary attributes. So I'm going to have it. And I'm going to have the same uProperty specifiers as my other. Right? For one, I want my category to say rep notify called doesn't exist. Use my attribute this to say, I'm just going to copy one of the health. And I'll go ahead and make my rep notify this to say strength instead of health. And I'll go ahead and make my rep notify. I'm just going to copy one of the others. Paste it here and call this on rep strength. And it's going to be the strength attribute. And it's going to take in old strength as well. Okay. Strength attribute, and it's going to take in old strength as well. Okay, that's not the only thing we need to do, is it? We also have a couple other steps. One of those is to go all the way up to get lifetime replicated props and add strength. I'm going to add a space between the vital and primary attributes. In fact, I'd like that. And this will be the strength attribute. So there's that. We make these new attributes. And strength, and I see that it's used, and it's going to be, also need my rep notify. the one for strength, click replace in the C line. Intelligence, I want to, and then highlight this line. Okay, so I have two more that I'd like to make. So I'm going to attribute is going to be, so I notify, replace all, and we can make the rep notify. For resilience, boilerplate, intelligence back up to get lifetime replicated, resilient, and we can, and in fact, I copied intelligence. So I need to replace intelligence, and we can, I'm going to generate the definition here. Replicated props are. I'm going to have one more primary attribute, do the same, and there we go. inline definition, get my gameplay attribute props. I have 4 new implemented, so that's good. No squiggles there. So we're good. Okay, so we have 4 new attributes. I'd like to do that, we have to expose a data table on that public folder here and open Aura player state where my ability system component variable is. And I'm going to add visible anywhere to the U property. Variable player folder in my component. Specific asset, a data table on that component. So I'm going to open my player folder in my public folder here and open Aura player state where my ability system component variable is. And I'm going to add visible anywhere to the U property. And then I'll go ahead and compile and launch the editor so that we can see the details panel in the ability system component. So you might have tried to look at the ability system component in the player state blueprint or perhaps in the enemy blueprints and seeing that the details panel is empty. And that's because we didn't expose our ability system component to the blueprint. But now that we have, we can go into our player folder, into Aura player state, open the full blueprint editor and choose ability system component. And now we can see the details panel in all of the properties. Now we can see the details panel in all of the properties. Now, if we want to use a data table to initialize some attributes, we have to add an element to this array under attribute test called default starting data. If we click plus, we now have this index, and you can see that it has an attributes property with a dropdown where you can choose an attribute set and a default starting table where you can choose a data table. Now, you can't just choose any data table. It has to have the correct row structure. So we're going to make a data table that has that correct row structure right now. I'm going to go ahead and create a folder for this. Let's go to blueprints, and where can we put this? We can go to ability system, right click new folder, and make data. And here in data, we'll make a new data table by going to miscellaneous, selecting data table, and which row structure do we want? Well, it's going to be attribute metadata. That's the structure that it has to be. Now, We can click OK, and we can call this dt underscore initial primary values. And we can open it up, and we can start adding some rows to this. Now, if I click plus add, you'll see that we have new row with base value, minimum value, maximum value, derived attribute info, and can stack, which is a Boolean. So what do we fill this in with? Well, we can change the row name. And if we change the row name, we have to specify the attribute. And the way that we have to do so is first by specifying the attribute set name, followed by a dot, followed by the attribute. So we can say aura attribute set dot strength, for example, and we can specify a base value. So I'm going to say 10 for the strength, save, and go back to aura player state and set the properties on this index for default starting date for the strength. Save, and go back to aura player state and set the properties on this index for default starting data. For attributes, set, save, and go back to aura player state and set the properties on this index for default starting data. For attributes, I'm going to choose aura attribute set, and for default starting table, I'm going to choose dt initial primary value. Values, compile, save, and let's press play. Let's do our show debug. And now look at this. We have lots of other attributes, and strength is set to 10. And it's showing our attributes more than once. But that's okay. The point is that strength is set to 10. And we can go in here and add a new row for the other attributes as well. We can say aura attribute set dot intelligence We can set intelligence to a base value of 17. Our character is a sorceress after all. And we can click add. We can do aura attribute set dot. I'm going to copy that. And this one will be resilience. This has to be spelled correctly, obviously. We'll set this to 11 and we'll have a new one. We'll name this aura attribute set dot vigor, and this will be 9. Save that, press play. Show debug, and we see that our strength, intelligence, and that's great. So this is one way to initialize your attribute values. And you'll see that we have min value and max value, as well as some other stuff here. Derived attribute info is not something that's exposed in this struct. Derived attribute min value and max value, as well as some other stuff here. Derived attribute info is not something that's exposed in this struct. And then, of course, we have can stack. Now, what do these other things do? Well, I'm going to go ahead and save all and close, and open up the attribute set class. So right-click on U attribute set. I'm going to go to declaration or usages. And I'm going to search for attribute metadata, and here's the struct. It says data table that allows us to define metadata about attributes, still a work in progress. Now, I'm not sure how long it's going to be a work in progress, but really the only thing this is useful for is setting the initial value for our attributes. It's not going to implement any sort of functionality for a minimum or a maximum. All it does is initialize the values. And for that reason, I'm not the biggest fan of using this method. And it's not the method we're going to end up using for our primary attributes. I just wanted to show it to you because for some cases, it is pretty handy. You can just fill out that data table, and the ability system component is just going to fill in those values initially for you, and that's great. But the preferred method that I like to use and that most people I've seen like to use is by applying a gameplay effect as soon as the game starts, for example. And that gameplay effect will set these and all of our other attributes. And that's what we're going to end up using. But now you know this method. And hey, the more you know, the better. So great job. And I'll see you in the next video. You can just fill out that data table. And the ability system component is just going to fill in those values initially for you, and that's great. But the preferred method that I like to use and that work in progress, but really the only thing this is useful for is setting the initial value for our attributes. It's not going to implement any sort of functionality for a minimum or a maximum. All it does is initialize the values. And for that reason, I'm not the biggest fan of using this method, and it's not the method we're going to end up using for our primary attributes. I just wanted to show it to you because for some cases, it is pretty handy. You can just fill out that data table, and the ability system component is just going to fill in those values initially for you, and that's great. But the preferred method that I like to use and that most people I've seen like to use is by applying a gameplay effect as soon as the game starts, for example. And that gameplay effect will set these and all of our other attributes. And that's what we're going to Welcome back. So we've just learned how we can initialize attributes with a data table. And I mentioned that that's not my favorite way. My preferred way is to use a gameplay effect. Now I'd like to add the ability to initialize our attribute values with a function that will apply this gameplay effect. And before we go and start doing that, I'm going to open the editor. And just remove that data table from our ability system component on the player state. Why? Because we're not going to use it anymore. It was just for educational purposes, but now that we're educated, we're not going to use it. So I'm going to select the ability system component on the player state. I'm going to remove this. I'm going to delete. That index from default starting data. So we're now no longer using it. And if I press play and show debug, all of my attributes have values of 0. And in fact, we don't see them twice anymore. Now I'm going to close the editor. And now we're going to work on applying a gameplay effect to initialize these primary attributes instead. So let's create the ability to do that. And I'm first going to add a function for doing this on the character. Our base character class can have some sort of default primary attributes gameplay effect. So I'm going to go into my public folder, into character, and open Aura character base. And I'm going to add a variable to the protected section. This is going to be a T subclass of. It's going to be of U gameplay effect. And I'm I'm going to call this default primary attributes. Now I want to be able to set this from the blueprint, so it gets a U property, and we'll make this blueprint read only, edit anywhere. And I'll put it in the category of attributes. So we have a default primary attributes. I'm going to want a way to apply these attributes. So I'm just going to make a function that can do it, and I'll put it right here in the protected section. It'll be void, and I'm going to call this initialize primary attributes. So let's generate the definition for this. And how are we going to do this? Well, first, if we're going to call something like apply gameplay effect spec to self or to target or something like that, we're going to need a gameplay effect spec to apply, which we can create because we have a class for our default primary attributes. So we can work backwards by first trying to call a system component, assuming that it's valid at the time we call this function. And from this ability system component, we can call apply. And I'm not getting the autocomplete because ability system component is an incomplete type here, which means I'll have to include its header file. I like autocomplete, so I'm going to go ahead and include that first, ability system component.h. And now effect spec get some practice. The to self version requires an effect prediction key spec. So how did we do it? See if you can remember. Try to remember without how do you make an effect spec. Now it's okay if you, and you can always go and look by remembering system component as a gameplay effect class, and we created one. Here on the base class, it's called default primary attributes. So that's what we pass in. It also needs a level, and we're just going to use level 1 for this effect. And then it needs a context handle. So we need to make that context handle. I like to work backwards like this and just comment these things out until I'm ready to fill them in. So I need a context handle, right? And so for that, I get the ability system component and I call, see if you can remember, make effect context. And this, if we hover over, we see it returns an f gameplay effect context handle. So let's make that f gameplay effect context handle. I'll call this context handle, and I'm going to uncomment the next line and pass in that context handle. Now this one, make outgoing spec returns an f gameplay effect spec handle. Let's make that f gameplay effect spec handle, and we'll call this spec handle. And then finally, we get to pass handle, and we pass in the ability system component. We'll just use get ability system component. Now, remember, we can't just pass in spec. So remember, the words syntax nightmare should come to mind. We have some things buried deep down inside the spec handle, right? We know that the spec handle has the actual spec, and see if you can remember, just from memory, what is that internal variable called that stores the actual spec? That would be data. But data is also a wrapper of its own. It's a t-shared pointer. Right? We have to use get, but it doesn't take a pointer, this function. Then this will work. So kind of a lot to do. The pointer, this function takes a const reference. So we have to dereference the pointer, and then this will work. So kind of lot to do. And of course, these can both be made const. So to be const correct and make this nice and squiggle free, we can put the const on both of those. And there we go. This is the version that applies a gameplay effects spec to a target ability system component, and we have to specify the ability system component when we use this one. And if we hover over this, we see that this function can be const as well. So we don't need to change the values of any variables. We're just calling functions on them. So I'm going to make this file and make it constant. As we have a valid gameplay effect class default primary attributes, then calling this function should be fine. We shouldn't have any issues as long as that is the case, and our ability system component is valid as well. And we can check those things. We can say check, and we can use is valid get ability system components. And we can also check default primary attributes just to make sure that that's not a null pointer that's unset. So now that we have this function, the question is, where do we call it? Now, we can call it in different circumstances depending on if we're the aura character or the enemy. In this video, I'm just concerned with setting our attributes for aura. So I'd like to open up our aura character CPP file. So I'm going to go to character and open aura character. And in aura character, I'd like to apply this effect. In other words, I'd like to call the function we just created in the base character class. We call that initialize primary attributes. But unlike init ability actor info, which we're calling on both server and client, words I'd like to call the Aura character. So I'm going to go to character and open Aura character. And in Aura character, I'd like to apply this effect. In other words, I'd like to call the function we just created in the base character class. We called that initialize primary attributes. But unlike init ability actor info, which we're calling on both server and client, applying this gameplay effect only really needs to be done on the server. Why? Because all of those attributes are marked to be replicated. So if we change them on the server, then they'll change on the client as well. However, if we wanted to do this on both client and server, that'd be okay too. We'd be setting these attributes to the same values on client and server, and that way the client won't have to wait for the server to replicate it back down. Either way is fine. Now, if we do it in replicated values on client and server, and that way the client won't have to wait for the server to replicate it back down. Either way is fine. Aura character. And in Aura character, I'd like to apply this effect. In other words, I'd like to call the function we just created in the base character class. We called that initialize primary attributes. But unlike init ability actor info, which we're calling on both server and client, applying this gameplay effect only really needs to be done on the server. Why? Because all of those attributes are marked to be replicated. So if we change them on the server, then they'll change on the client as well. However, if we wanted to do this gameplay effect info, which we're calling on both server and client, applying this gameplay effect only really needs to be done on the server. Why? Because all of those attributes are marked to be replicated. So if we change them on the server, then they'll change on the client as well. However, if we wanted to do this on both client and server, that'd be okay too. We'd be setting these attributes to the same values on client and server, and that way the client won't have to wait for the server to replicate it back down. Either way is fine. Now, if we do it in init ability actor info, we know that our ability system component should be valid by this point, and it's clear by looking in this function. So we can just do it here after ability system component is set, since we know that it should be safe to call it there. So I'm going to call it here, and what we call it initialize primary attributes. So we'll call it right here in init ability actor info. So now all that's left is to make sure that we have that effect and that we configure some default values. So I'm going to go ahead and run in debug mode so that we can create that effect that sets our initial primary attribute values. Now I get some compilation error. So the first one says an Aura character-based gameplay effect is an undeclared identifier. We didn't forward declare gameplay effect. I'm going to go ahead and do that up here at the top. Then I'll go ahead and compile again. And that solves all of our problems. So when I have multiple fix, it's usually only a couple. Okay, is a gameplay values and character. Start off with clever, so create one for Aura. And we're going to make a new folder here in ability. We're going to make a new folder called primary attributes. Effects, an ability system called gameplay effects. And here in gameplay effects, we're going to make a new folder called primary attributes. And in primary primary attributes, we're going to make a new gameplay effect. So let's make this gameplay effect, and we're going to call it effect attributes. And in primary attributes, we're going to make a new gameplay effect. So let's make this gameplay effect. And we're going to call it GE Aura Primary Attributes. We're going to open it up. And this will be an instant gameplay effect. We're going to apply it once. We're already calling the function to apply it. And we're going to have 4 modifiers, one for each of the primary attributes. So I'm going to click plus. One, two, three. 4 times and expand the first one and pick from among our attributes. I'm going to choose attribute set.strength. Modifier op, though, is not going to be add. It's going to be override. Yes, they will have values of 0. So adding this initial value to it will give us this same result. But we're going to override just because this is the value that it should start off at. For the modifier magnitude, we're going to set the scalable float magnitude. And for Aura's initial strength, let's give her 10. And there's our strength. Let's go to the next one. For the next one, we're going to choose intelligence. We're going to set modifier op to override. Modifier magnitude, we'll give her, let's say 17. And there's our intelligence. Next, we'll choose our resilience. Modifier op will be override. Modifier magnitude. These might not be the same values I chose earlier, but I'm going to choose 12. And then for the next one, finally, we have vigor. It's going to be override, and the magnitude can be 9. So we should see 10, 17, 12, and 9. I'm going to compile that, and now we have our gameplay effect. We just need to set that, and that's going to be on the Aura character itself. So into character, Aura, BP. P Aura character blue attribute E Aura prime debug, and there we have it. We have strength 10. 10, Intelligence 17, Resilience 12, and Vigor 9. So pretty simple. We kind of already knew how to apply gameplay effects, didn't we? But this is my preferred way, and this is the most common way I've seen it done. I think it's a good way, and it works as long as we apply the gameplay effect at the beginning of the game, then we get our default attributes. And later, when we decide that we need to load in some attributes from saved data, it's pretty simple to do that as well. Once you know how to apply an effect and specify the magnitude at runtime, and we'll learn how to do that too. So now we know two different ways to initialize our attributes, actually three ways. One is through the attribute accessors in code. That's currently how we're doing our health mana, and max mana. We'll fix that later. We're going to handle these in time, but now we're using a gameplay effect for our primary attributes, which is great. So excellent job, and I'll see you in the next video. Welcome back. Now, so far, all of our gameplay effects are using scalable float for their modifier magnitudes. For example, if I open actor and potion, Welcome back. Now, so far, all of our gameplay effects are using scalable float for their modifier magnitudes. For example, if I open actor and potion and G GE potion heal, and I scroll down, I can see that right here I have a single modifier. It's modifying the health attribute, it's adding to it, and the modifier magnitude calculation type is set to scalable float. Now the dropdown shows us 3 other options, and attribute based is the next one after scalable float, and attribute based is quite an interesting and useful option for magnitude calculation type. It's actually very cool, and it gives us the ability to have an attribute change based on other attribute values. This can make it really easy to have an attribute that is derived from other attributes. So in order to see how attribute-based gameplay effects work, I'd like to make a new effect actor that applies a test effect that uses attribute-based modifier magnitude calculation types. So let's go ahead and create one of those. So first, here in Actor, I'm going to make a new folder called Test Actor. And here in Test Actor, I'm going to make an effect actor and a gameplay effect. So I'll start with the effect actor, searching for Aura effect actor. And I'll call this BP underscore test actor. I'm going to open it up, and I'm going to give it a box collision. And here in the event graph, with the box selected, I'm going to use on component begin overlap. And we'll call apply effect to target. So we'll go ahead and hook these up. And I'd like to make a gameplay effect to apply, and we can just make it an instant gameplay effect. So I'm going to get the instant gameplay effect class, and we can make a gameplay effect and apply that. Now, for testing purposes, I'm going to make the box a little bit more visible. I'm going to select my box and set my line thickness to something a little bigger, perhaps 5. And I'm going to search for the rendering section and uncheck hidden in game. Compile, save, and now I have my test actor, and I can just drag one in right here. Now we just need an effect to apply. So let's make that. I'm going to create a new blueprint class, gameplay effect, and I'll call this GE underscore test attribute based. And open that up, and we'll go ahead and configure this, but first I'm going to go to my test actor and set its instant gameplay effect. So all the way up at the top, we have instant gameplay effect class. It's going to be GE test attribute based. We don't care about the instant effect application policy because we're just calling apply effect to target directly. Okay, so now we can configure this gameplay effect. It's going to be an instant gameplay effect. So all we need to care about here is adding a modifier. And if I click plus to add a new modifier, I can expand it. I can choose an attribute. I think I'll go ahead and choose the health attribute. And for modifier op, we can leave it at add. And for modifier magnitude, I'm going to expand it. And for the magnitude calculation type, instead of scalable float, I'm going to choose attribute based. Now, as soon as I do that, suddenly we have this attribute based magnitude, which we can expand. And we have quite a few options here. And we're going to discuss all of these, but for now, just ignore the first 3. We'll talk about these shortly. But take a look at backing attribute, expand that, and we have the option to choose an attribute to capture. And we can choose the attribute source. You see, this gameplay effect is going to be caused by something to something. So we can capture the attribute from the source or the target. Now, I'm going to choose target because we're applying this gameplay effect to Aura when she overlaps with it. So I'm going to capture attributes from Aura. Now, we'll talk more about Snapshot later in the course. It has to do with when to capture the attribute. When should we use that attribute's value? Should we use it when the gameplay effect spec that caused this gameplay effect was created, or when it was applied? Snapshot determines when exactly we'll be capturing that attribute. We're going to leave it unchecked for now, but we're not really going to discuss it until we have a situation more appropriate to consider it. Now, for the backing attribute, we can choose an attribute. And since I chose target for the attribute source, then we know that we'll be taking that attribute from Aura as soon as she overlaps with our box component on test actor. And if I choose one of my attributes, for example, the vigor attribute, then by default, all we're going to do is add, since our modifier op is add, we're going to add the value of vigor to our health. So let's see this in action. I'm going to go back and press play. I'm going to show debug ability system, and I see that my health is 50 and my vigor is 9. So as soon as I overlap with this volume, now I see that my health is 59. Why? Because we had vigor added to it. We had the value of vigor added to it. So that seems simple enough, right? But the thing is, with all these options, this can get complicated very quickly. And we know that we can add multiple modifiers. For example, what if I collapse this index for my modifiers and I click plus on the modifiers bar one more time? Now we have 2 elements in this array. And if I expand this one, I can choose to have another modifier. Now let's say I choose health again. So I have 2 modifiers modifying my health. And I can leave this as add. And let's say that I expand modifier magnitude, I change the calculation type to attribute based, I expand attribute based magnitude, and expand backing attribute. And this time choose a different attribute like strength. And I choose the attribute source to be target. So now I'm going to collapse this. My modifiers array has 2 elements in it. They're both set to add for their modifier op, but the first one is backed by the attribute vigor. The second is backed by the attribute strength. Now, you would just expect to have vigor and strength added to our health. Well, let's see if that's the case. I see that my health is 50, vigor's 9, and strength is 10. So if I overlap, now my health is 69. It was 50, we added 9, and we added 10. That equals 69, so it works as expected. Now, when all of our modifier operations are just add, then it's pretty intuitive. We just add them all together. But it's important to understand exactly how these modifiers work and how the order is taken into account. So we're going to have a more in-depth conversation about how these modifiers are applied and how it works depending on what the modifier operation is. And after we do that, we're going to then start talking about these additional parameters, coefficient, pre-multiply additive, post-multiply additive, and so on. so that we understand completely how all of these things work. So called test actor, effect actor, and a gameplay effect. So I'll start with the effect actor, searching for Aura effect actor, and I'll call this BP underscore test actor. And I'll call this BP underscore test actor. I'm going to open it up on components, I'll place up, graph, box collision, and here in the event graph, I'm going to open it up, and I'm going to give it a box collision, and here in the event graph, with the box selected, I'm going to use on component, apply, effect to target. So we'll go gameplay effect to apply, and we can just make it an instant gameplay effect and apply that. I'm going to select my box and set my line thickness to something a little bigger. Perhaps 5. And I'm going to search for the rendering section and uncheck hidden in game. File save, and now I have my test actor, and I can just create an effect, new blueprint class, gameplay effect. Based. And open that up. And we'll go ahead and configure this, but first I'm going to go to my test actor and set its instant gameplay effect. The test attribute base calling apply effect to gameplay effect is adding a modifier. And if I click plus to add a new modifier, here is adding a modifier. And if I click plus to add a new modifier, I can expand it. I can choose an attribute. I think I'll go ahead and choose the health attribute. And for modifier op, we can leave it at add. And for modifier magnitude, I'm going to expand it. And for the magnitude calculation type, instead of scalable float, I'm going to choose attribute based. Now, as soon as I do that, suddenly we have this attribute based magnitude, which we can expand. And we have quite a few options here. And we're going to discuss all of these. But for now, just ignore the first three. We'll talk about these shortly. But take a look at backing attribute, expand that. And we have the option to choose an attribute to capture. And we can choose the attribute source. You see, this gameplay effect is going to be caused by something to something. So we can capture the attribute from the source or the target. Now, I'm going to choose target because we're applying this gameplay effect to Aura when she overlaps with it. So I'm going to capture attributes from Aura. Now, we'll talk more about snapshot later in the course. It has to do with when to capture the attribute. When should we use that attribute's value? Should we use it when the gameplay effect spec that caused this gameplay effect was created or when it was applied? Snapshot determines when exactly we'll be capturing that attribute. We're going to leave it unchecked for now, but we're not really going to discuss it until we have a situation more appropriate to consider it. Now, for the backing attribute, we can choose an attribute. And since I chose target for the attribute source, then we know that we'll be taking that attribute from Aura as soon as she overlaps with our box component on test actor. And if I choose one of my attributes, for example, the vigor attribute, then by default, all we're going to do is add, since our modifier op is add, we're going to add the value of vigor to our health. So let's see this in action. I'm going to go back and press play. I'm going to show debug ability system. And I see with this vol head, so that can get codifiers. For example, plus on, and if I use health again, action type 2, backing the attributes array op, backed by the attribute and strength. I see that my health is 50, vigor's 9. It was 50. It works as add. Then it's pretty intuitive how these modifiers work and how the conversation works depending on start talking about post-multiply additive. And in the next video, we're going to take a deep dive looking at the modifiers and the order of operations depending on what our modifier ops are. Welcome back. We're now going to talk about the modifier order of operations. Now, we've seen that when we just add multiple modifiers and they're all affecting the health attribute, and they all have their modifier op set to add, then the result is pretty simple. We take our health attribute and add the value of the modifier's backing attribute. Here we have first our vigor attribute backing the first modifier. And then we have our strength attribute backing the second. And as you would probably guess, if we added another one, and we chose the health attribute yet again for this one, we left it at add, and if we set the magnitude calculation type to attribute based, and we set our backing attribute to yet another attribute, such as resilience, choosing our attribute source to be target, then I think you could guess what's going to happen, right? Obviously, the attributes will be added together. So starting at a health of 50, if we overlap, we see that our health becomes 81, which is 50 plus 9 plus 12, which is resilience, plus 10. That all equals 81. So it's as expected. But let's talk about what happens if we change these modifier operations a little bit. But let's talk about what happened at 9 plus 12, which is resilience, plus 10. That all equals 81. So it's as expected. But let's talk about what happens if we change these modifier operations a little bit. And as we're making different changes, I'd like to make the math simple for us. So I'm going to go ahead and close out and in the attribute set, I'm going to initialize the health to 10 just so we can make our math a little bit easier to understand. So let's talk about the different operations. So we're now initializing our health to a value of 10. And we know that we can add a modifier to a gameplay effect, choosing an attribute to effect. So far, we're just and for attribute-based modifiers, we choose the back to have a value. Otherwise, if we add modifier op with the backing, will be that is with another add modifier 12 gets added applied back to the attribute, gets the addition of the first strength, comes out to 41. Our health was 10, and we add added 9 plus 10 plus 12. It's a 10 now. Let's editors modifiers is backed by strength. Now we're starting off with 10 health. Our health becomes 41, just like in the slide. So our understanding correct. Modifier, which is modifier op. So the only thing we're going to change now, then the second, to have our health team. So then the vacation equals 202. Let's see if this math checks out. So back in our test attribute based, we want to change that mil modifier so that its modifier op is now multiply. So we'll change that. The other two are still add. Let's go ahead and press play, show debug. Health starts at 10, and as we overlap, we see that our health is actually 100 because we're clamping, aren't we? Let's go ahead and undo that. Clamping. I'm going to close the editor, and back in our attribute set, where clamping and pre-attribute change, I'm going to comment out both of those lines, and here as well. Okay, so, and we'll make sure, and now that we remind ourselves, health goes to 202, our modifier, but instead of add. Now, then the send is 1990. Going to have, that's 12. Calculator, we're going to point modifiers out. Modifiers as they are. Let's go ahead and overlap. Our health becomes 15.8. Okay, so we understand that well. If we add a fourth modifier, let's say that, so what happens if we add a fourth modifier? Let's say that its backing attribute is max health, and its modifier op is set to add. So how does this change things? Well, the result of the first three will simply be modified by the fourth one. So we get our health, we add vigor, that's the first modifier. The result of this is multiplied by the strength, that's our second modifier. The result of this is divided by resilience. And the result of this entire thing will then be added to by max health. So before it was 15.83, we're adding 100 to that, so the result should be 115.83. Let's make sure that math checks out. So back in our gameplay effect, we're going to add one more modifier to the modifiers array. We're going to expand it. We add attribute-based attribute and set that attribute. So now that we understand the order of operations of our modifiers in a gameplay effect, we now can mix and match and make a gameplay effect change an attribute based on any number of other attributes. And you're probably wondering, pre-multiply additive value and post-multiply additive value. Well, the truth is we can make the mathematics, and we're going to see how they work in demised. Well, the truth is we can make the Welcome back. So now that we have an understanding about the order of operations of our modifiers, let's talk a little bit more about some of these settings, specifically the coefficient and these pre and post multiply additive values. You see, just being able to multiply, add, subtract, or divide an attribute by another attribute isn't quite enough. What if you wanted to add to your health a value equal to strength times 10, or strength times 0.1, or strength times 0.1 plus 12? These are where we can do this kind of thing. Now I'm going to remove that fourth modifier there, so we just have the 3. Let's talk about what happens if we start to set those coefficient values. So the 3 parameters we're interested in are the coefficient, the pre-multiply additive value, and the post-multiply additive value. Let's talk about exactly and then are to set those coefficient values. So the 3 parameters we're interested in are the coefficient, the pre-multiply additive value, and the post-multiply additive value. Let's talk about exactly how these work. Now, we have a modifier. Let's say it's backed by vigor, and its modifier operation is add, and vigor has a value of 9. Now, an attribute-based modifier has these 3 parameters, right? Well, the amount added to our health is going to be affected by these 3 parameters as follows. Vigor has a value of 9. We first add the pre-multiply additive value. Then this result is multiplied by the coefficient, and the result of that has the post-multiply additive value added to it, which makes sense. Vigor is multiplied by a coefficient. It just happens that we can add a value to vigor before multiplying by that coefficient, and then we can add a value after all that. So we can add a value before multiplying the coefficient, and we can add a value after multiplying the coefficient. This gives us some flexibility. So we have this formula applied, right? And let's say we have a modifier backed by health, modifier op add, with a coefficient of 0.1, a pre-multiply additive value of 2, and a post-multiply additive value of 5. So what does this modifier return? Well, first we take the 9 and add the pre-multiply additive value, which is 2. The result of that, which is 11, gets multiplied by the coefficient, 0.1. So 11 times 0.1 would give us 1.1. The result of this then gets the post-multiply additive value added to it. So 1.1 plus 5, and the result of this is 6.1. So that's how it works. So if we have these 3 modifiers, each with their own modifier operations, and backed by different attributes, all targeting health, and we give them each these parameters, then each of them will get the same formula applied, and the result returned from them will be the result of this math. So let's just say that we want these coefficients and these pre- and post-multiply additive values for the modifiers that we have. If we do have those values, and these are the results returned from those modifiers, then we should expect our health to be added to by 2.2. The result of this should be multiplied by 19. The result of this should be divided by resilience, and that should all come out to 7.26 as long as we use these parameters for each of our modifiers. So I'd like to make sure that this math checks out. So as we can see, our first modifier backed by vigor is going to need a coefficient of 0.1, a pre-multiply value of 3, and a post-multiply value of 1. So let's get our first modifier. We'll expand modifier magnitude, expand attribute based, and set the coefficient to 0.1, the pre-multiply additive value to 3, and the post-multiply additive value to 1. Now, according to the math that I did, this should come out to 2.2. 9 plus 3 is 11. 11 times 0.1 is 1.1. 1.1 plus 1 is 2.2. Feel free to double check any of this math if you like. Now, for the next modifier backed by strength, we want a coefficient of 0.5, a pre-value of 6, and a post-value of 11. So let's open up that second modifier, expand our dropdowns, and set the coefficient to 0.5, set the pre-multiply additive to 6, and the post-multiply additive to 11. And we see that that should come out to 19. And for our last modifier, we'll use the values 2.1, 0.5, and 5.7. So let's expand our dropdowns for our last modifier and use 2.1 for the coefficient, 0.5 for the pre-multiply, and 5.7 for the post-multiply. Now, as we see, the result of all of this should come out to 7.26. Let's see if that's what we get. We'll press play, show debug, and overlap, and there I get 7.26 just as expected. So as you can see, we have some freedom when it comes to backing our attributes by other attributes. And this is quite nice, and it gives us a lot of flexibility, although it's not complete flexibility. We can't just create some arbitrarily complex calculation this way. To do that, there are other methods available to us in GAS that we'll get to soon enough. But this way, at least we know we can have attributes backed by other attributes, and we're going to learn in the videos to come how we can have derived attributes, which will always be derived from the values of other attributes. So when its backing attributes change, it will change automatically, and we'll see how to do that very shortly. So excellent job, and I'll see you soon. Welcome. So now that we know how we can use modifiers to apply modifications to attributes, and that those modifications themselves can be backed by other attributes, this opens a very important door when it comes to RPG-style attributes, and that is the door to derived attributes. In other words, attributes that depend either partially or entirely on other attributes. Now, in our game project, every single one of our attributes is going to be functional. It's going to affect the game in some way that's important. And it helps from a game design perspective to lay out what all the attributes in the game should be doing. Now, we won't be discussing all of them just yet, but we'll discuss most of them right now because we're going to design more attributes and decide which attributes are dependent on other attributes. Now, so far, we've decided to categorize some of our attributes as primary attributes. And in our game, the primary attributes are going to be the independent attributes that don't depend on any other attributes. These are the attributes that are standalone, and we can increase them or reduce them based on various mechanics in our game, but it's these attributes that in some way or another all other attributes depend on. These are the 4 primary attributes we've created, starting with strength. Now, every attribute affects the game in some way, and we need to decide how the attributes affect the game. And this is a decision made at the design level. You could come up with different ways than I come up with, and ultimately in a game development team, there's some sort of design process, some sort of meeting or series of meetings where those in charge of designing the game agree upon the mechanics of how each attribute affects the game. And for this game project, decisions had to be made. So I made them, but I understand that you may have ideas for how you'd like your attributes to affect your game. So don't take these as chiseled in stone. Don't take them as gospel. I've just made some design decisions because they had to be made. And you may have other ideas and you'd like to implement them differently, and that's totally fine. And at this stage, as a game developer, I think you're capable of making those decisions and implementing things in your own way if you so choose. But do feel free to copy my design and just follow along exactly if you don't feel like sitting down and making those design decisions just yet for your own game. In this game, strength is going to increase physical damage. Now, we haven't gotten to damage yet. We're not implementing it at this point in the course, but when we do, we'll have different types of damage, physical being one of them. And strength is going to be an attribute that will add some kind of bonus to attacks which cause physical damage. Now, that's not the only thing strength can affect in the game, but this is going to be the defining characteristic of strength, the description given to strength when you hover over it in your attribute menu. Intelligence is going to increase magical damage. Resilience is going to increase armor and armor penetration. Now, I know we haven't created those yet, but that's how I'm going to define resilience. And vigor is going to increase health, the most vital of all the attributes, perhaps. So these are the decisions I've made for the primary attributes. But what about other attributes? What about secondary attributes? In this game project, secondary attributes are going to more closely affect gameplay mechanics, mostly combat, and these will be attributes that are derived either partially or wholly from other attributes. The secondary attributes I've decided to create are as follows. Armor. Armor is going to depend on resilience. As resilience increases, armor is going to increase by a certain amount that we decide. The definition of armor is that it reduces damage taken and improves block chance. Next, we'll have armor penetration. Armor penetration is going to be dependent on resilience, and it's going to ignore a percentage of enemy armor and also increase the critical hit chance. So as we attack an enemy, if we have a high armor penetration, that value is going to cause us to ignore some of the armor of the enemy we're attacking, allowing us to cause more damage, and also increase the chance to get a critical hit. Next, we have block chance, which will be dependent on armor. Notice, this is a secondary attribute that depends on another secondary attribute, so these don't have to all depend solely on primary attributes. Block chance will be the chance to cut incoming damage in half. So in our damage calculations, we'll take block chance into account, and if we get a successful block, we're going to reduce the incoming damage by half. Next is critical hit chance. Notice armor penetration increases this. So this will be dependent on armor penetration, and as armor penetration increases, so does critical hit chance, and this will be the chance to double the damage plus a critical hit bonus. So if we get a successful critical hit, our damage will be doubled. Next, we have critical hit damage. This will also be dependent on armor penetration, and this is the bonus damage added when a critical hit is scored. Next is critical hit resistance. This will be dependent on armor, and this will reduce the critical hit chance of attacking enemies. So as an enemy may have a high critical hit chance, if we have a high critical hit resistance, we can sort of balance that out. Next is health regeneration, and this will be dependent on vigor. So vigor increases health, yes, but it also increases other things. Health regeneration will be the amount of health regenerated every 1 second. So a periodic infinite gameplay effect should come to mind here, right? Next, we'll have mana regeneration, and I'll have mana regeneration dependent on intelligence, and this will be the amount of mana regenerated every second. Then we'll have our max health, which will be dependent on vigor, and this will be the maximum amount of health obtainable. Now, we already have this attribute. We called it one of our vital attributes. But I'd like to now consider this to be a secondary attribute, as I'd like it to be dependent on one of our primary attributes, the vigor attribute. And finally, we'll have max mana, and this will now be dependent on intelligence. This will be the maximum amount of mana obtainable. So as our intelligence goes up, so will our max mana. So as you can see, we have quite a few secondary attributes that we're going to add to our attribute set. And adding attributes to an attribute set is something that we now have experience in doing. So this is going to be your quest. Your quest is to add all the secondary attributes to your attribute set. Now, you can come up with your own, or you can use the list that we just went over. Complete all the boilerplate steps for each attribute. Now, this involves declaring the variable, adding the rep notify in your U property, and defining that function. Make sure it's a U function. Also adding the attribute accessors macro for each of the attributes. And in your rep notify, use the gameplay attribute rep notify boilerplate macro. And also add each attribute to get lifetime replicated props, so you can register it as a replicated variable. So pause the video and add all of your new secondary attributes now. Okay, so since this is mostly boilerplate, in fact, it's all boilerplate, I'm going to add all of the attributes and time-lapse the video, as this is all repetition at this point, so as a replicated variable. So pause the video and add all of your new secondary attributes now. Okay, so since this is mostly boilerplate, in fact, it's all boilerplate, I'm going to add all of the attributes and time-lapse the video, as this is all repetition at this point. So if you like, you can follow along, pause or slow the video down, but these steps will all be repetition. Okay, I think I'm just about done. And just to recap on all that I did here, I first added our secondary attributes, and I made sure to have a multi-line comment to show where these secondary attributes began. So I added the secondary attributes here, giving them both the uProperty and attribute accessors, making sure that the uProperties have on rep for the rep notify for each of these attributes. And that's something to double check, as it's really easy to copy and paste and forget one of these steps. So I have the on rep notifies for each one. I then declared the rep notifies for each one and defined them. I also moved my max health and max mana here into the secondary attributes out of the vital attributes. So now our vital attributes only consist of health and mana currently. And max health and max mana, I'm going to consider them secondary attributes, as they will be dependent on other attributes. Next, I went into the CPP file and added the definitions for each rep notify using the boilerplate gameplay attribute rep notify, so we can inform the ability system of the replication, and of course added each of the secondary attributes here in get lifetime replicated props, making sure to specify each one, and now we have those attributes set to replicate. So really 4 key steps, right? First, declare the variable. Next, use the rep notify or create one. Make sure the rep notify has the gameplay attribute rep notify macro, and then add that rep notify to get lifetime replicated props so it's replicated. And now we have our new secondary attributes, and these are going to be based on the other attributes. We know how we can apply an effect that's based on other attributes, but we want these attributes to always be affected by any other attribute. We want them to change when their backing attributes are changed. And we're going to do that next.